Hey, hello, workshop students. Let me do an example problem of 1D motion with constant acceleration. Now, I did a video right before this that I would encourage you to go look. It was a little long-winded, but it took some time. It starts with here, and it goes through 3 pages. And the idea was to get you to see why, when you are doing an acceleration problem, or excuse me, a kinematics problem with constant acceleration, you want to focus your attention then on at least these 2 equations, perhaps these 3, maybe even these 4, and maybe even this 5th one, okay? Depends how far you want to go. But if you haven't got a chance to watch that video, go watch it, because here's what I was trying to say. I was trying to say that if you have these 4/5 equations with these 5 parameters, focus your attention on which one is missing, because then the other 3 will be given with looking for the 4th. Okay, and so that's how I'm going to start this problem. All right, so these 3 pages is what I worked out in the previous video. But what was important about that is it had equation 1, equation 2, equation 3, and where'd it go? Equation 4, and really kind of mostly ignored equation 5. And I was encouraging you to memorize definitely 1 and 2. Perhaps it's probably 3 is a good idea, but even to 4, but really never to 5, okay? And I'm going to focus my attention because as I look at the problem given in the homework, which it looks like number 5 and number 6. I'll go number 5 here. And I didn't print it up, so I'm just going to write it here. It says, in this little box here, it says V naught, V, T, and X. And it just says X, but I think what the author means is calling 0 position at X equals to 0. This is just equal to X. You see, and the problem reads something like this. It says an airplane begins with an initial velocity, and that's not given. Then it accelerates at a constant rate of A, which is not listed, but it does say it's constant rate, for a time of T. And they give 18.6 seconds. Its final velocity v, and the plane has moved a distance x during this time. So we've got this distance of 4,871 meters and a velocity of 299. Okay, so what I'm trying to point out here is that which one is missing? Well, clearly the A is missing. Which equation then would be appropriate? Well, position is missing from number 1, so not that one. Velocity, final velocity, is missing from number 2, not that one. Time is missing from equation number 3, so not that one. Number 4 is missing A. See, focus your attention on which one is missing. They will give you the other 3, and you can find the 4th. And that shows up perfectly here in equation number 4. So I would put distance traveled, so that is 4,871 meters. I would then say that is the initial velocity plus final velocity divided by 2, and then multiplied by time of 18.6. And so now I can get out my calculator and do my work and figure out what I get for an answer here. So, turning on my calculator and clearing it, I'm going to take the 4,871 and first divide it by the 18.6. So that brings that over to here. Then I'm going to multiply by the 2, so that brings that over. And then I'm going to subtract the 299, and I get an initial speed of 225 meters per second. So that's what I wanted to illustrate. That's why I went through that long video ahead of time. Focus on which one is missing. Now, as long as I've got your attention on this one, number 6 then has a box, and I should have printed this, but it's still talking about this same airplane. And the box 1, 2, 3, 4 has acceleration, initial velocity, time, and position. And before I fill in what's given, let me focus on what is missing. Okay. Now, again, I think the author means here take the starting of the airplane as being 0, so the initial position being 0 is also just the x. Okay. All right. So if I look at this, what's missing is final velocity. And if I scan my equations again, equation 1, position is missing. That's not it. Equation 2, final velocity is missing. That's it. This is the one I want. Okay. That's the one missing. So I'm going to write that one down. Distance traveled is equal to initial velocity times time plus 1/2 at squared. And so 1, 2, 3, those are the 4 variables. I will give them in 3. I can solve for the 4th, and I don't need to worry about the 5th one. Again, that's why you always focus your attention first on which one is missing. That's kind of a key step. All right, so if I put this in, this would be 3.92 for the acceleration of the airplane this time. The airplane has an initial velocity of 217. The time is the unknown one to solve for, and the distance the airplane travels is the 4,538 meters. So I'm going to put all that in and solve for time. So this is 4,538 for the distance, 217 times time, 1/2 of 3.92, and t squared. Now, this one involves a little more math than the last one because it is a quadratic equation. So let me write the quadratic equation in the standard form, and that is to write it in descending order set equal to 0. So this is the power of 2, so I'm going to put that one first, and then this one I'm going to move the distance to the other side so I have a negative. And so now I have a quadratic equation, and if you remember from your algebra class, the solution is something that looks like this. Okay, where b is the coefficient in front of the linear term, a is the coefficient in front of the quadratic term, and c is the constant. So if I put in the opposite of b, I get 217. If I put in b squared, I'll just write it as 217 squared minus a 4 times an a, which is 1.92, times a c, which is a negative 4,538. And then if I divide that all by 2 times a, 1.92, we get what? All right, well, let me start with this one, 217 squared. The minus and the minus make a plus. 4 times 1.92 times 4,538. And taking the square root of all of that makes the 286.3 over, and then 2 times that would get us back to 3.92. All right, so we've got two answers. The first one using the plus sign. So let me do that one first. And so that's a 17.7 seconds. And let me do the minus sign, which, whoops, minus 217, and then minus 286.3 divided by 3.92. I will get a negative 128.4 seconds. So this one has an added piece to it, and I'll talk about the answers, but let me just kind of summarize and wrap it up here. Again, notice I looked for the equation of the one that was missing. They gave me the other three. I can solve for that, which in this case had to be distance. Now, the math turned a little harder because it was quadratic. And because it was quadratic, the math gives me two answers. And of course, you can obviously say that, wait, physically, there's only going to be one answer, right? And so which one is the right one? Well, that's where you have to take a moment to kind of interpret and make sure you read the math. What do these mean? Remembering that at time equals to 0, that's the initial speed. And this problem goes off that says an airplane begins and then it accelerates at its final speed. So its speed is going faster, and its speed would be something a little bit faster, which we didn't solve for that faster speed. We could now that we have these parameters, but they don't ask for it. But the real key is the time later. So that alone tells us that the time has to be greater than 0. And so if we compare a positive one with a negative one, we can say, well, this has got to be the right one because it's got to be a positive time. Now, that doesn't mean there isn't anything called negative time. I want to be careful with that. I've heard students say, well, there is no such thing as negative time, so this one doesn't exist. And no, that's just not really a fair statement. You see, what does initial speed mean? See, initial speed is the time, or excuse me, the initial speed is the speed of the airplane when time is equal to 0. It might be when you start your stopwatch. So this airplane looks like it already has a pretty good speed. So the airplane may be started back here, and if it's a takeoff, it starts going faster, 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 and when it gets to right here, you start your watch. So at that point, that's when time equals to 0. That's when the speed is 217 meters per second. But all of this before, back here on the tarmac, that is where time is less than 0. And then going forward, the time is greater than 0. So to say time cannot equal to 0 is not a good statement, because time can be less than 0. You started your watch partway down the runway. And obviously time before that existed. There was a time where you were, at rest at the end of the tarmac. There was a time when you boarded the plane. There was a time when you got to the airport. There was a time when you were born. All of these would be negative time if you call time equals to 0 partway down the runway. So please never say that time can equal to 0. That's just not a fair statement. But it is a fair statement to say we don't want that for our answer. We want a time later on and a positive one. And so therefore we can rule that out. There is a meaning to this, and I probably shouldn't take time in this video to say that this has a meaning, and it's probably worth thinking about the mathematics of what does this actually mean. But in this case, we can rule it out. Now, this would have been harder if both of them came out to be a positive one. And so I would say, Read these, understand what both of these numbers mean. And the truth is, they both have meaning, and you can't just throw one out because it's negative and say negative time doesn't exist. They both could be negative, they both could be positive, or one could be positive and one could be negative. Now, fortunately for this one was positive, one was negative, and it was very easy to rule out the negative because we know we want one that a time is greater than 0. It would be like, asking what time did they land. Again, you know that it's got to be a positive time once you start your watch. Or if the problem said, what time did you get to the airport? Well, in that case, you would want the negative one because your time equals to 0 is when you're halfway down the runway. And you got to the airport before you got onto the runway. So you want a negative time. So if you're going to call your initial speed 2.17, that's when you're calling your time equals to 0. And so I'll say it again. If the problem said, what time did you get to the airport? You would want the negative one, not the positive one. But in this case, it's the other way around. We want the positive and not the negative. All right. Well, hopefully that was helpful. Enjoy.